Welcome back, everybody. It's been quite a while since the last video, and I have a small announcement to make. I now have a professional film technician helping me, the wonderful Robin Schubert. I'll put some links in the description where you can check out his work. In this video, I'd like to talk about this room, which is my studio and also kind of the room where I sleep in. So I want to talk about how I built it and how this amazing lighting setup that you can see right now came to be, and all the other cool features of this room. So we're gonna be shooting some pics and videos today about all the small features. I moved into this flat with a couple of my friends from university about a year ago, and I always wanted to have my own studio/video room. But of course, as a student, you don't really have a lot of money, and also the space in here is a bit constrained. At first, when I moved in, the room was really like wet sounding, and if you clapped your hands, you could hear a lot of reverb from the corners and edges. So the first thing I wanted to do is put in some acoustic panels. I started my planning using measurements I took from the empty room. I then added this line at 38% of the room's total length. It's usually a good starting position for finding a good spot for acoustic monitoring, because the bass interference isn't all too bad at that point. After that, I sketched out my furniture. To get my lower frequencies under control, I added 2 large couches to my studio. On the ceiling, you can see the 4x4 grid of acoustic absorbers. I wanted to avoid bolting the absorbers into the ceiling one by one. So instead, I decided to build a wooden support structure. I mounted the 2 main support beams on the far sides of my room. They will later hold the almost 5-meter long struts. Because I wasn't able to transport parts that long, I bought 3-meter wooden beams and then extended those using small boards and screws. In total, I built 24 of the acoustic absorbers. 16 for the ceiling, 4 prismatic ones for the corners of my room, and 4 sliding ones. I spent quite some time to figure out the cheapest way to build all of the panels. As the core material, I used stone wool, the type usually used for insulation. It's great at absorbing high-frequency echoes, and it also helps to get the bass frequencies under control. To frame the stone wool, I built rectangular boxes using cheap wooden planks. After inserting the wool, I applied some gaffer's tape to keep it from falling out. Finally, to give the panels a cool look, I wrapped them in black blankets that I got from my local furniture store. It might have seemed maybe a bit weird to walk out of that store with a shopping cart filled with cuddle blankets. Using small chains, I mounted the ceiling panels to the wooden support beams. This allowed me to quickly change the height of all the panels' corners to get everything aligned properly. After mounting the ceiling panels and stacking the prismatic ones in the corners, I still had some annoying high-frequency echoes from the remaining walls. I fixed that using thin absorbers for high frequencies that I got from a friend. I mounted the panels about 50 centimeters below the ceiling, and that offset kind of improves the way the panels dampen, especially the low frequencies. Fortunately, we have pretty high ceilings in here, so I was able to do that without kind of crushing the height of this room. Behind me you can see the custom-made studio desk. I've always wanted a desk that you can raise mechanically so that you can just stand up and keep working when the vibe is going in the studio. While making the studio desk, I focused on having enough space to put all my studio gear on it, and I also wanted to have a slider for my piano under it. This sphere over here represents my head, and I aligned it in a way that it forms a triangle with the monitor speakers, and that I sit exactly under this 38% room length line. For the setup of the 2 PC screens, I would have preferred a side-by-side layout, but then I would have covered the studio monitors, so I went with this above each other setup, and I tilted the lower one so that I can still look at it perpendicularly. After finishing the desk design, it was time to sketch out all the arcs onto a wooden board. This actually took several hours because I ended up using a piece of string with a pencil attached to it. Some of the arcs have a radius of over 6 meters, so I was lucky to have all that space in my friend's garage. After cutting out and sanding the shape of the desk's main board, I continued building the shelves for the speakers. The last steps after everything arrived in my studio were to mount the desk stand, construct a drawer for my MIDI piano, mount the 2 PC screens, and get all the cables managed. And this is the result. It's actually as big as I'd hoped, so I have enough space to put all my stuff everywhere. I also added a motorized stand beneath the desk so I can use it as a standing desk while I'm producing, and the piano slider also works as intended. What took quite some time was the cable management, because I'm running a lot of power and signal lines between all the devices and away from the desk. I used these little cable manager tie thingies to tidy everything up, and now it looks pretty nice and you can't see most of the cables. In this room I have 3 windows, and of course I didn't want to completely cover them with acoustic panels to still let some sunlight in while I'm working. My first try to mount the sliding panels was using a cheap plastic curtain rod, but unfortunately that broke almost instantly. On the second attempt I used alloy rails with plastic gliders, and that system is working pretty well so far. A few drops of silicone oil really went a long way to help the sliders run smoothly. This is one of the sliding panels. It's a bit larger than one of the ceiling panels. And if I extend all of them, then I can completely cover my front window to avoid high frequency reflections, and I can still open the window when all 4 sliding panels are retracted. The next part of this room that I built, and probably the most extraordinary, is the giant ceiling LED matrix. Basically what I did was I put a lot of LED stripes between the acoustic panels on the ceiling. I also put some diffusers around the LED stripes so that you can see the individual pixels. So now I have a giant ceiling sunlight LED matrix pleasant work light thing. The LED matrix is based on 12-volt RGBW LED strips, where each pixel can be controlled individually. The fact that these LED stripes run on 12 volts really helps bring down the current draw in comparison to the standard 5-volt variants. This means that I could run longer lines of LED strips without having color errors due to voltage drops, and that I could use a less bulky power supply. In total, I used about 25 meters of LED stripes in my studio. I chose LED stripes with a color temperature of 6500 kelvins on the white channel, because I much prefer the look of cold white over the yellowish tone of warm white LEDs. To keep the stripes cool and to prevent the blinding effect when looking directly into an open LED pixel, I added some alloy profiles with milky plexiglass diffusers. After cutting everything to length with the help of a friend and soldering all the connections, it was time for a dry test. Watching an LED matrix of this size come to life for the first time was a really cool feeling. To mount the individual bars of the LED matrix, I used the same chains as for the acoustic panels. I found cheap plastic rings that were large enough to thread 2 of the LED modules through crosswise. Over one of the ceiling acoustic panels I dedicated as an access hatch, I mounted the power supply unit, LED controllers, and an Ethernet network switch. The control signals for the LED matrix are generated by custom Python code running on my Raspberry Pi behind the studio desk. They are transmit via the lighting control standard ArtNet to 2 Arduinos in my ceiling, which translated back to signals the LED stripes can understand. If any of you guys are interested in building an LED matrix of your own, then please notify me in the comments and I can share my hardware schematics and the software snippets with you. I built a small website that I can access from my PC, my smartphone, and my self-made light switch inside my studio, which allows me to control important parameters of the LED matrix, including the brightness and the color and a few fun effects. I made a new interface a few days ago where you can directly draw onto the pixels of the ceiling matrix, so you can make really cool lights for filming, for example, or just get creative when your friends are here and basically everyone can draw with their smartphones or on a computer, and you can do like an interactive Microsoft Paint game. There are also a few fun effect settings for listening to music, and if you're just in the mood for chilling. Last but not least, of course I can't control the ceiling LED matrix properly with just a normal light switch. So I built a small device that emulates a light switch, and it has a couple of faders and buttons, and with that I can control the brightness and the color and other features of the ceiling light. Starting out building the digital light switch, I found this metal housing that I modified to hold 6 cherry key style buttons and 2 faders. After spray painting in black, I wired everything together, added some LEDs for backlight, and an ESP32 chip for wireless communication. I built the backplane out of a white scrap piece of plastic and bodged its edges black with an edding. The electrical power to my desk and to the power supply unit of the LED matrix are managed by wireless power sockets. I can turn those on and off manually using my phone, or turn them on automatically at a set time to use my LED matrix as an alarm clock in the morning. And because I know those systems can always fail and turn on while I'm not here, I have a kill switch that I press when I'm gone, so the power to everything is cut. So that was a quick room tour through my finally finished studio. If you have any questions or are interested in some of the specific parts, then please just write it in the comments. We'll make more videos in the future, not only about my dorm room, but also about engineering and fun technology projects and woodworking. So if you want to be a part of that, then please subscribe. See you then. Bye.